Welcome. Let's look at this JAMB past question physics 2018 question number 23. A lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meter per second into a lead block of mass 0.95 kilogram. Given that the lead block can move freely, the final kinetic energy after impact is A. 150 joules, B. 100 joules, C. 50 joules, D. 200 joules. Now, for us to be able to appreciate this question very well, we need to understand the formula of conservation of energy and momentum when there is an impact due to firing. Now, whenever you hear impact due to firing, you're gonna be able to note that you'll be having the initial mass of this lead bullets multiplied by its velocity plus the mass of this block onto which it is making impact, m2, multiplied by the velocity before the impact. Now, after there is an impact, you're not going to have the two masses m1 plus m2. Now the masses are together, they are now moving with one single velocity v. So this is the right expression to solve this. This is the bullet and this is the block. So this bullet goes into this block to form a bullet and a block together, moving now. So this is moving, making this impact to form this. So this is what equation that we have, and from this equation we can calculate this final velocity. With this final velocity we can now calculate the final kinetic energy to be equal to half mv squared. So this final velocity, we need it to do this calculation. We know these initial velocities and masses, but we don't know this final velocity. So that is what we need to calculate. Once we calculate it, we can put it in this formula for kinetic energy to find out our kinetic energy, and that is what we are going to be doing. So make this v the subject of the formula. We have v to be equal to everything here. We have m1 u1 plus m2 u2 all over m1 plus m2. So that is v. So with that we can say that our v is equal to m1 is what, 0.05 times u1 is what, 200. We are given initial mass is 0.05. this is the initial velocity for that. Then plus m2 is what, 0.09. this is our m2 here, 0.09 times this bullet went into this block. This block was not moving initially, so the u2 is 0. So all over m1 plus m2. m1 is what, 0.05 plus m2 0.09, I mean 0.95. So if we solve this out, we are going to be getting 10. That's what we'll get, because this times this will go 1 2 to cancel these 2, so that we have 2 times 5, which is 10, plus this times 0 will give us 0, so we have 0 here, all over 0.05 plus 0.95 is 1. So we have 10 plus 0, which is what, 10 over 1, which is 10. So v is equal to 10. From this calculation, our v is equal to 10 meter per second. So having v as 10 meter per second, we can now calculate ke, which is kinetic energy, which is giving us half m. The m is the mass, the total mass, which is 0.05 plus 0.95, half m times v square, and v is what, 10 to power 2. So v is 10, so square is 2. So here we have 0.05 plus 0.95, which is 1. So 1 is what we are going to do. So we are still going to have half times 1. So we have half times 1 times 10 to power 2. and 10 to the power 2 is what? 100. So we simply have this is equal to 100 all over 2, because 1 times 1 is 1, 1 times 10 to the power 200. So this is 100 over 2, giving us the final answer as 50 joules. And C is the right option for this, which is 50 joules. So you can see how we came about this by quoting this initial formula for impact whenever there is collision and we have one thing colliding with the other with their initial velocities and their masses to form this final velocity when they are now together. So if you make this v the subject of the formula, you get, using the values we have, noting that the velocity of the lead block is 0 because it's not moving, we'll get v as 10. So if we put it in this equation for kinetic energy, which is half mv squared, we'll get kinetic energy as 50 joules, which is the answer. Thank you.